how does the rocket engine work? So I tend to think air-breathing engine sucks and the rocket engine blows. So meaning like rocket engine is a thrusting device to thrust your vehicle, but compared to air-breathing engine, you don't have any air to carry for the space. So you have to carry both oxidizer and the fuel, and you combine those things together to convert the chemical energy to kinetic energy and create the thrust.
So fundamentally, the purpose of a rocket is to deliver a payload to space or to orbit. To do that, you need to get the rocket moving at high velocity, which means that you need to generate a force to accelerate the rocket. Rockets work through the principle of conservation of momentum. So we are exhausting mass at high velocity out the engine, which reacts the rocket to have thrust. The first thing I'm going to talk about is the combustion chamber, which is effectively the last component on the vehicle. So we get thrust by combusting gas and exhausting it downward, which generates a force that moves the vehicle upward. The reason that combustion chambers are shaped like this is because when you have a converging and then diverging nozzle that gets to a sonic speed at the throat, where the Mach number equals 1, you're at the speed of sound, you can accelerate a subsonic flow to a supersonic flow and get the fastest exhaust velocity. Somehow we need to get that flow rate into the combustion chamber. So specifically how a gas generator cycle works, which is our engine cycle. Ours has 2 turbo pumps, a gas generator, and again that combustion chamber. We've got propellant that comes in from the tanks and then comes out of the pumps at high pressure. Pumps increase the pressure and drive that mass flow rate to the combustion chamber. And that's how we get the propellant to the engine to burn. We use pumps to increase the pressure and flow rate of the flow that goes to the main combustion chamber, but somehow we need to drive those pumps. So that's where the turbine and where the gas generator comes in. So we tap off just a little bit of that flow of fuel and of oxidizer, and we burn that in the gas generator. We're getting power from burning the flow, and then we're exhausting that over the turbo pumps. So that exhausts over the turbine and the turbo pumps. That spins the turbine, which shares a shaft at the pump, so that spins the pump, and that's what allows it to increase the pressure and drive that flow rate of the fluid through the system. Somehow we need to control that flow. That's what's going on at steady state, but we need to start up and shut down that flow. So we have valves in the main lines and in the gas generator circuit, and controlling those valves is actually one of the most complicated things on the engine. When we run an engine hot fire test, all we're doing is clicking valves in a sequence, but determining that sequence and setting the red lines that keep the engine safe if it moves in an off-nominal way is the really challenging part of engine development.
This engine is massive, like in terms of the thrust, and that really excited us. I think we can do very unique things about it in the next iteration of the engine.